Hi, and welcome again to our series on exponents. We have looked at ways of writing exponents down, and we have multiplied and divided with powers. Let's see if we can combine our multiplying and dividing skills in some examples. By the end of this lesson, you should be able to simplify expressions by multiplying and dividing powers. Can you write 3 to the power 41 times 3 to the power 20 divided by 3 to the power 12 in a shorter way as a power of 3? The bases are the same, so we can apply the laws of multiplication and division. Let us put down the base. Now, what about the exponents? Since there are no brackets, we must work from left to right. So we'll end up with 3 to the power 41 plus 20. Why? Because 3 to the power 41 times 3 to the power 20. Our first law, it says we add the exponents. Second one, we subtract 12. Why? Because the law says if you are dividing, we can subtract the exponents. That will give us 3 to the power 41 plus 20 gives us 61. 61 minus 12, that will give us 49. Look at the difference between 3 to the power 41 times 3 to the power 20 divided by 3 to the power of 12, 3 to the power 41 divided by 3 to the power 20 multiplied by 3 to the power of 12, and 3 to the power 41 divided by 3 to the power 20 divided by 3 to the power 12. You can get quite confused if you do not think carefully about the order of operations here. We can write the first one, 3 to the power 41 times 3 to the power of 20 divided by 3 to the power of 12 as 3 to the power of 41 multiplied by 3 to the power of 20 divided by 3 to the power of 12. And the second one, 3 to the power of 41 divided by 3 to the power of 20 multiplied by 3 to the power of 12 as 3 to the power of 41 multiplied by 3 to the power of 12 divided by 3 to the power of 20. And the last one, which is 3 to the power of 41 divided by 3 to the power of 20 and divided by 3 to the power of 12 as 3 to the power of 41 divided by 3 to the power of 20 divided by 3 to the power of 12. Remember that for any number, when you are dividing, you can multiply by the inverse of that number. So we can multiply by 1 over 3 to the power of 12. And that will be equals to 3 to the power of 41 divided by 3 to the power of 20 times 3 to the power of 12. Now, let's simplify this. We have already done the first one, but have another look. Let's carefully look at where our operations appear, the multiplication and the division. Remember our first law. We said when we multiply, we can add our exponents. So that means we'll have the 3 to the power of 41 plus 20 divided by 3 to the power of 12. That will give us 3 to the power of 61. Now we said if we are dividing, our second law says we can subtract our exponents. Therefore, that will give us 3 to the power of 49. Our second example is different from the previous one. Can you see the difference? Look where your operations are this time, your multiplication and your division. Right. This time we're multiplying with 3 to the power of 12 instead of dividing with 3 to the power of 12. So there again, apply your first law, 3 to the power of 41 plus 12 divided by 3 to the power of 20. If you add 41 plus 12, that gives us 53. So we'll have 3 to the power of 53. We take away 20. That will be equals to 3 to the power of 33. In the third example, both operations are divisions. That's here and there. This can be confusing, so we'll take it one step at a time. Right, let's look at this. Remember we said if we are dividing, it means we have to subtract. That will give us 3 to the power of 41. You take away 20, and you take away 12. That will give us 3 to the power of 41 take away 20, that gives us 21. 21 take away 12, that will give us 3 to the power of 9. Let's look at this example with variables. In this example, we have x to the power of a divided by x to the power of b multiplied by x to the power of c. Can we write this example as a power of x? Remember the laws? When you multiply powers of the same base, you can add the exponents. When you divide powers of the same base, we can subtract the exponents. Okay, the bases are the same. So let us put down the base x. Are you ready to write the exponents? Look carefully where the multiplication and the division signs are. They will tell you when to add and when to subtract. So, the first one, we give an x to the power of a, we're dividing by x to the power of b. Remember our law says if you're dividing, that means we can subtract. And the last one, we're multiplying with x to the power of c, that means we can add our exponent c. We will need to practice this, so let's do a few more examples. Write this number, a to the power of 24, a to the power of 12, and a to the power of 2 divided by a to the power of 15, a, as a power of a. Note, if we don't write multiplication signs, it still means multiply. First of all, are the bases all the same, namely a? Yes, so we can use the laws of exponents. Let's see. We can apply our first law there. A to the power of 24 multiplied by a to the power of 12 times a to the power of 2. First law says if you're multiplying, we can add the exponents. Therefore, we'll have a to the power of 24 plus 12 plus 2. We'll do the same thing at the bottom. It will be a to the power of 15. If it's only a, that will be the same as a to the power of 1. So we add plus 1 there. That will give us a to the power of 38 divided by a to the power of 16. It's division now. Second law, that means we can subtract. It will be a to the power of 38, take away 16. That will be equals to a to the power of 22. Good. The laws make it easy for us to simplify expressions containing powers. Can you simplify this one? We have a power of a and a power of b. We give an a to the power of 13, b to the power of 13, divided by a to the power of 10, and b to the power of 11. Since this is division, that means we can subtract our exponents. But now we have to subtract the ones with the same basis, a and a, b and b. That will give us a to the power of 13, take away 10, multiplied by b to the power of 13, take away 11. That will give us a to the power of 3 times b to the power of 2. Here are the important things to remember from this lesson. We saw that to multiply powers with the same base, we must add their exponent. And to divide powers with the same base, we must subtract their exponents. Just remember that these laws only work if you have powers with the same basis? Can you multiply and divide numbers that are written as powers? Check yourself by doing this task. Simplify. Number 1, a to the power 7 divided by a to the power 2 multiplied by a to the power 5 multiplied by a to the power 2, all divided by a. Number 2, b to the power 12 multiplied by c to the power 7 divided by b to the power of 9 multiplied by c to the power of 7. Number 3, 10 to the power 3 plus 10 to the power 2 multiplied by 10 to the power 2, all divided by 10 to the power 7 times 10 to the power 3 divided by 10 to the power 4. Watch out, this one is tricky. Well, our time is up, folks. I hope you've enjoyed working with powers. In our next lesson, we'll see how we work with numbers and powers. Salani kahle.